in my calculator. I think this one turns out okay, I hope. It's doable to see. This is another one to make sure that you kind of have everything in the right spot. So parentheses might be helpful in this case. Oops, see, like right now I put the squared in the wrong spot. I want to make sure that it's down on the bottom with the X. Your graph looks something like mine, hopefully. What's up? It's like whatever, for whatever reason that flat off, we don't want that highlighted to hit enter again. Anytime we get that error, I don't know why that keeps flipping itself back on. Wait, I think it's like where you hit enter, yeah, in that line. Yeah, but that's an okay question to ask. Yeah, if you guys are ever in a calculator, I mean, obviously I don't want to teach you how to do your calculator the day of the test, but if you're getting an error message in your calculator, I'm glad to look at it. Like, I don't want you guys to be like error message in every question. Like, if it's a problem like this, and there's like 8 questions about the same problem, your test is just like all of a sudden blown if you can't solve that one question. So, and this will happen. I'll try to break it up a little bit, but there are going to be multiple questions about the same graph. And if it helps for you to even sketch what your graph looks like for me so I can see, because I can't obviously look at your graphs after the test. So it might be worth even drawing a quick little sketch of this is what my graph looks like, just so that I can kind of see your work, kind of, if that's helpful, if that makes sense. So, finding the relative maximum. Now this one is an actual maximum. So in this case, it's just that highest point. But when they talk about the maximum, which value are they asking for? They don't want 1, 2 as their maximum. What are they asking for? It's the y. So the max in this case, so the relative max would be y is 2. That's the highest this graph seems to go. And when it talks about a relative maximum, it basically is saying like in a certain like range of values, like where's the highest it goes. And then the minimum, so this would be max. And then our min is -2, right? All right. The next one says, list all the intervals where x is increasing and then all the intervals where x is decreasing. So now intervals is talking about something different. Intervals is the x values, like the range of x values where the graph is increasing versus decreasing. Where is the graph increasing? From where to where? The x values we want to look at. Yeah, so the increasing section would basically just be from here to here. So it's just this little part, I believe. And so we'd say it's increasing. And this is where we want to use that interval notation. It's from x is greater than -1 but less than +1. And again, you could use the equal symbols if you wanted. So it's increasing on those values from that little section there. How about decreasing? It's a little bit confusing because of like this, because it kind of levels off, but technically it's going downhill. It might be really, really gradual up here. It's decreasing all the way this way. As much as that seems strange because you're pointing that way, it's going downhill here. So it's when x is what compared to -1? Less than -1. And forever, like forever that way. And then same thing over here. So when x is greater than positive 1. This one technically is never like constant because it really is always approaching, getting smaller and smaller. It's decreasing at a really like slow rate, I guess, as it gets further down the line because it's leveling off. Okay, so that's increasing and decreasing. Now it asks about limit notation. And so again, being comfortable with that limit notation and not getting freaked out by the symbols. Hopefully by now you're past that. You're not gonna. All right, so the limit notation. Oops, not that one. So the limit on, and this one's approaching infinity, so to the right, again, this is where we talk about my hands. What would my hands be doing on the right side of the graph? Approaching what? Not infinity, that's where my hand's going, but like, what's the y value at that point? It's headed towards 0. So as my hand goes as far to the right, picture my arm stretching out, my graph is getting closer and closer to 0. So it's asking for the value of the function. I know that's confusing, so it's going to go towards 0. And then my left hand is doing what? Also 0. So what's the horizontal asymptote then? There is one. And what's that equation? Y equals 0. And it's been a while since we talked about this, so that's why I was kind of trying to bring all those up. And then the last thing, it says give the domain and range for the function. So looking at this graph, domain and range is what's the possible x values that make sense for this function, and then what are the possible y values. Now x, we have to decide, is there like a limit to what we can choose? And this one's a little bit of a strange one. So we've talked about that, remember, like if there's a fraction or if there's a root, or if there's a fraction and a root, we have more to think about. But the graph also helps us with this, hopefully. What x values can I choose for my domain? So that's the possible x values. Are there limits to what I can choose for my x? No, this is kind of weird because it's in the denominator, so it might make you think, remember we don't want the denominator ever to be 0, but since that x is being squared, there's no way for that denominator ever to be 0, and the graph helps us with this. Is we go along the face of the graph and we never see there being like a gap or a weird like hiccup in the graph where it looks like it doesn't quite work or if it totally misses an x value. There is no value of x that we could substitute in, because if you put -1 in, it becomes a +1. So it's never going to be 0 in the denominator because of that squared. So the domain, we say x can be anything, so we say all real numbers. We can use the fancy little r symbol that shows that x can be anything. But we did talk about the denominator cannot equal 0. You can't have a negative in a root. So those are important things to kind of remind yourself of. But this one didn't have any of those limits. And then how about the range? That's the possible y values. How high and low does this graph go? From -2 to +2? It'll never, from what we can tell, it'll never like somewhere down the line all of a sudden like go way up or something. It looks like it's basically just between -2 and +2. That's as high and low as this graph goes. And I did use equal this time because of the fact that it is on that point. Is that okay? Does that make you feel a little bit better about kind of those graphs, kind of going back to that a little bit, kind of refreshing your memory? I do have a worksheet for you guys. I will get